Hello, good morning from Linz. I hope you can hear us. Welcome to our first webinar from Re-FREAM. Today it's about the challenge from 2D to 3D. And our first input session is ready for you on the link you can find in the description. And I will show it to you in a second. Please have a look at the video and come back later at 10:15 for any Q&A. Later at 10:15 for any Q&A.
Hello all together. I hope you can hear me well. Welcome to our first Re-FREAM webinar. My name is Verena Traunmüller. I'm the Re-FREAM project manager from Creative Region here in Linz, Upper Austria. And today I'm here together with my colleague Sander Hofstee.
Hello, my name is Sander Hofstee. I'm from the Fashion and Technology Department at the Art University of Linz. And I'll be offering design expertise for our 2D to 3D challenge.
Later today, following this webinar, our technological partners from the hub in Linz, they are going to explain their technologies to you in detail. You can see the schedule for the webinars on our homepage. And also a very short and important message is that please note that during this webinar, we cannot have any live questions from you. Means we cannot talk to you directly right now. This is unfortunately due to our technical setup here. But of course, we are able to answer all your questions later on. So please, in case of any questions, please post them to the chat. We will collect them, cluster them, and we'll talk to you and discuss with you right after this presentation. But please note that it's not possible to ask any questions directly during our presentation. So please use the chat function. Okay, so I want to start with a little introduction of the Re-FREAM project itself. But I promise I keep it short because I'm sure you all are already informed a little bit about the Re-FREAM project itself and had a look on our website. So I will just shortly give you a little input to this. The mission of Re-FREAM is to start co-creation processes. We want to start co-creation between artists or designers, as you are probably, and scientists. And the aim of this co-creation is that artists or designers and scientists can co-explore how technologies can improve or even change the future of fashion. Through this process of co-creation, both groups, meaning artists and scientists, they will both benefit from mutual learning. Through the process, they are able to rethink their own way of doing, rethink their own work. And through this, both groups are enriched by getting new perspective that will help to change the future of fashion. The technological partners within Re-FREAM are offering a fully geared up infrastructure with state-of-the-art technology. This technology is currently not used in large-scale production within the fashion industry, but within Re-FREAM, our partners offer the chance for artists and designers to experiment with those technologies, and they let them use them to realize their concepts. So within the co-creation process, Re-FREAM wants artists and scientists to research, for example, on new materials or new processes that are able to change the future of fashion production. Also, Re-FREAM has a very strong focus on urban manufacturing, means it wants to make use of these state-of-the-art technologies to let urban areas becoming a space of art-inspired and design-orientated production spaces again. We do not only want to challenge the fashion itself within Re-FREAM, but especially in our challenge here in Linz, we want to challenge the way how fashion is designed and produced. Re-FREAM in general is a project that lasts for 3 years. It's financed by the European Union and it offers 2 rounds or 2 calls where we are searching for artists and designers. The first call is currently open and still will be open until the 30th of May. And in each round or with each call, you as designer or artists can apply for one of our 3 challenges. We will talk about challenges in a minute. You can apply to a challenge with your concept and by describing how you would experiment with technologies to rethink fashion. And the selected concepts will have a duration of 9 months and you can receive up to 55,000 euros per concept or project. Each of our 3 challenges have their own technological partners, and by applying for one certain challenge, you will have certain technologies available to you. The challenges will take place in different locations, and the locations are also our co-creation hubs. It means those are the spaces where the co-creation processes actually takes place. And those hubs will be located in Berlin, Valencia, and one is here in Linz. We are currently working on establishing them. In Berlin, the challenge or the hub is focusing on technologies that work with the integration of electronics. And the webinar for those technologies will take place tomorrow on the 8th of May. So if you're interested, you can come back tomorrow and dive into technologies used in the hub in Berlin. In Valencia, the focus is on sustainable circular systems, and the webinar introducing the technologies available in the hub Valencia will take place this Wednesday on the 9th of May. And we here in Hub Linz, we are focusing on additive manufacturing. And later today, directly after our session, our technological partners from our hub will present their technologies to you. But now I will hand over to Sander and he will give you some more details to our challenge from 2D to 3D.
I would like to tell you a bit more about the 2D to 3D challenge which takes place in Hub Linz. The hub is managed by the Creative Region Linz in Upper Austria and the Fashion and Technology Department of the Art University in Linz, who will support the artists. We are looking for game changers. This means that we need big ideas, concepts that challenge the status quo. Think of complete processes instead of one garment or accessory. You should be able to rethink traditional methods of creation and production. Come up with your own aesthetic vision that combines the functionality of 3D printing and wearability. Yet you should keep in mind that these visionary ideas should still be rooted in reality. Your goals should reflect the technical possibilities available to us now and in the near future. You do not need to be a 3D printing expert already, but it is important that you are able to visualize and communicate your concepts and ideas clearly, and that you are motivated to dive deep into this technology. You should be keen to learn the digital skills needed for your specific project. Throughout the whole project, the artist will receive support and feedback from our network. From initial concepts to visualizations to final prototypes, we've got you covered. Our challenge is called From 2D to 3D because traditionally in fashion, patterns are created in 2D to ultimately fit 3D bodies when all the pieces come together. It is important to be able to work like this and visualize how a pattern will be transformed, but we are really interested in what happens in the creative process if we switch straight to 3D for this creation stage. We challenge our participants to come up with visionary concepts that combine fashion and additive manufacturing technology to create new processes for the creation and production of fashion. Our network of experts are eager to be challenged by your creative vision. Together, we will research, experiment, and develop prototypes in our co-creation space. The upcoming seminars will dive a bit deeper into the different technologies which are offered by our hub partners. First off, we're going to have Haratech, which have technologies such as laser cutting, injection molding, vacuum casting, and 3D printing. Then we have Profactor and Stratasys, who will show 3D printing technologies such as Polyjet printing. And afterwards, Empire will talk about simulation technologies.
Last but not least, I shortly want to introduce you the place where our co-creation hub will take place, here in Linz. Linz is the main city of Upper Austria, and Linz is no traditional fashion city, but Linz has a lot of industries and institutions that are developing and researching technologies of the future. And therefore, Linz is the perfect place for our challenge that Sander just introduced to you. Linz is within the top 5 creative cities of the European Union, And the Re-FREAM hub here is located in the innovation center of the city. It's a place called Tabakfabrik. And we in the Hub Linz and all the partners, we are not only offering to you a wide range networks to persons in design and technology field, but also we are having collaborations with, for example, the Ars Electronica Center or the Garage Makerspace. So we hope you got a little insight to the Hub in Linz and to our challenge. Thank you for your attention.
So get ready to be inspired, and we look forward to seeing your concepts for the From 2D to 3D challenge. We will now be live and taking questions. Please use the chat to interact with us, and I hope we can answer all your questions.
Great, so one person already wrote that the video works. I hope for the others too. In case of any questions to our challenge from 2D to 3D, any questions for Re-FREAM in general or for the application process, we're happy to answer them. Okay, so the first question was how much time our artists or designers will spend in the hubs. So the case is that we expect your project to have a duration of 9 months, and 30% of this 9 months you will spend in the respective hub. It is dependent on your project if you will spend the whole time in a block or if you will come back and forth to the hub. So this is very open to you and depends on your needs. But it is mandatory to spend at least a minimum of 30% of this 9 months in your hub. Any other questions to the challenge or to the application process? Okay, the next question is if we or you as an artist have to deliver a model or a prototype in order to apply, and I hope our design expert, Sander, can answer this question for you.
Yes, I also see a model or prototype or just an idea. We're mainly looking at this stage for ideas, big ideas that we can then together with our scientists can research, develop an experiment, and then go towards models. So the quick answer is no, you don't have to deliver models or prototypes just yet.
Is the question answered? Maybe it's also good to know that at the end of the project, we expect you to have a prototype ready at TRL6 stage. So at the end of the project, it really should be a prototype. Another question is if there is any possibility to have a check on the proposal in advance. And here I can tell you, you are really welcome to address our help desk. They can give you feedback, they can help you with your application, and also can check with you if you're on the right track or on the right way so far.
Yeah. So another question from Team Amsim, technology enabling digital manufacturing by pre-programmed 3D shapes in the flat plane. And the question is, can we develop this digital side further with your experts? That is hard to answer because we're obviously not familiar with your technology yet. But if it fits within the 2D to 3D challenge, I'm pretty sure we would be interested in seeing it, and you should definitely put that in with your proposal. Then another question, do we need to have our patterns digitalized? I would say that for this challenge, we don't really look at the traditional way of working with patterns, which is 2D. We are really trying to get straight to the 3D. So we urge you to not think of this challenge and fashion in general in the traditional way of starting in 2D and then going to 3D.
Then we have another question in the chat regarding if the scientists can help in finding the right circular economy materials, and if we could elaborate a little bit more on the collaboration process. So basically it's about a co-creation, meaning scientists and artists are co-exploring and researching together on, for example, certain materials, as this was the matter from the question. And to this particular question, I can say you are addressing the circular economy. This is the focus in our hub in Valencia. They have a webinar on Thursday this week. And if you're interested in the technologies they are using there, you can jump in this webinar. But of course, since it's in general a co-creation process between scientists and artists, of course, there should also be a collaboration on finding out materials and researching together. I hope that helps a little.
And this ties into the question about where do you do the practical part of the 30%. This is based in one of the 3 hubs that the challenges are linked to. So that is either Berlin, Linz, or Valencia.
Then there is an administrative question. How much of the 55,000 euros can be spent on hours of the team? Here I can tell you, please have a look at our guide for applicants. It's available on the homepage. You can download it there. And we provided there a scheme where you can find the maximum borders for spending your budget on different categories. And there is also the limit for how many euros you can spend on hours of your team. Please have a look in there. And if you have any further question to this, please contact the help desk. So especially for staff costs, it's a maximum of 35% of your total project budget, meaning depending on how much your total budget is, 35% maximum can be spent on staff costs. So then there is another question, if budget for development is eligible. So if this is part of your concept and if you're budgeted as a team member, then you should also consider the maximum percentage of staff costs that are possible. But since this is a really specific question, I think it's important to have a look on the whole project you're currently working on. Please contact us for this very specific question via email on the help desk, and we can dive deeper to this and give you more details on this question. Studio Frederic, this was your question. Please contact us via email. Also for the frameworks we are suggesting, this is very specific. Please write us. We are happy to help you here. Are there any other questions? When will the winners be announced? So actually, our call is open until the end of May. And afterwards, we have a jury that is evaluating your proposals. And probably in July, we are happy to announce the winners. Another question is if you can apply for more than one challenge. Here it is important to say that we will have 2 rounds of calls. So you can apply, of course, now for the current challenge, but also for the second round, you could apply again.
So another question about the technologies in Linz. Please stick around in this webinar because we're going to switch over to our technical partners, and they will be explaining their technologies that are available to you in the Hub Linz.
And the technologies are also listed on our homepage. If you have a look there, you can also get an overview of technologies that are available. The second round, there was a question, when do we have planned the second round? It's probably next year. We yet don't have a certain date for an open call, but of course we will inform you, and it will be next year. And if you're in the Re-FREAM newsletter, you will get the information as soon as we have planned it. Are there any other questions? If yes, of course, you can still write us via email by contacting the help desk. And now the next webinar is from Haratech about the technologies in laser cutting, injection molding, and vacuum casting. And I'm happy to hand over to my colleagues from Haratech right now. Please hang on.
So we are back. I hope the link worked out for the technologies what Taradec is offering, and you're free now to pass your questions and we will answer them hopefully. Shubha Mahanjan, can you be a bit more specific with your question? Yes, it is possible. So Shubha, is it possible to create 3D designs for surface? Is your question? The answer is yes. There are other questions related to our video or technologies what we have here in Linz. So at Karin, she's writing, how does it work in Linz, the collaboration? Of course, it's in our facility, we are doing the practice stuff, we are doing the engineering together with the artists, of course. So we have our engineers reserved for a certain time on these days where we can exchange our knowledge and work out your ideas properly.
Regarding the question from Michael, is 3D scanning available at Taradec? Yes, we have different 3D scanning possibility. We have also a 3D body scanner in our house and also an industrial machine for special accuracy. So you can measure colored part and also standard parts in our house. And we have also innovation lab where it's possible to work with our experts in our house for your projects.
Petra Meyer, to your question, if Brazilian can apply, this depends on if your business is done in Europe, but you can refer. Send your question to the help desk and they may answer you properly.
Frederick, regarding your question, yes, we have also the 3D printing technology for molds in our house, and we developed also special plastic molds for injection molding process for small quantities. So it's also possible to integrate different inlay materials in the plastic mold. So maybe it should be a good idea for your project.
Maybe for Studio Frederick, additional info, Hardtech has several printing technologies available in-house. It's not only limited to FDM, you have also Polyjet technology, SLA and multi-jet fusion technology. We have one printer which can combine several technologies. It's laser engraving, it's milling and printing in the same printer.
Shuba, yeah, it's possible you can put the texture on your 3D shape and we can print it out with the texture and also with the color. It's possible, but depends from your software possibilities. So maybe if you are using some artist programs like ZBrush, Maya, and so on. So with these programs, it's possible to give the texture directly on the 3D shape, and so it's also possible for us to print it out with the color and also with the texture.
To the question of Studio Frederick related to electronic experts, we have tomorrow a webinar with Berlin, Hub Berlin. They are focusing on the electronics, especially combining textiles and electronics. So you can pass your questions tomorrow to them. So, Studio Frederick, to your question, if we can at Hub Linz integrate the electronics in the 3D parts, of course this is possible. If it's integration into textiles, there is of course, even if you have the main challenge in Hub Linz, access to Hub Linz. So there will be a collaboration as well with Hub Berlin to get access to their knowledge and technologies. Are there other questions to our technologies? Karen, you're asking if we have a calendaring machine. Here in Linz, Hardech has no access to such a machine, but I think even if we do not have this technology, we might find another solution which fits your needs. So maybe send your specific questions or your idea to the help desk, and we can see what we can, as an alternative, provide you. Said already several times, even if we do not raise a question now, we are still open to answer them during the chat, and as well you can post it on our help desk. I want to highlight that one of our colleague, Julia Kastner, is writing that Hub Valencia has access to calendaring machine. So on Thursday there will also be a webinar specific to this topic, and I think you can raise your questions there. So if you do not have further questions, we will introduce you to Profactor in the next minutes. They are our experts to Polyjet technology, and they are supported today by Naomi from Stratasys directly. To your question, Karen, machine engineers, can you be a bit more specific? We have engineers in designing, in engineering, in different fields. We have engineers for 3D printing technologies, for injection molding and CNC technologies available here at Hardech. To Nina is asking if the webinar can be rewatched if you cannot attend. The answer is yes. They will be published on our official website after they are finished. on, we assume, beginning of next week. Frederick, to your question, if is it possible to work together with chemists doing experiments in polymers, as my colleague Leo Schranzhofer wrote already, he is one of these experts, these chemists. Of course, there is the possibility to work with them, especially in the Profactor facilities. So we will hand over now to Profactor. Haradek, of course, will stay in the chat and we will follow and answer your question in written form.
Thanks, Kevin. Thanks, Kevin, for the kind introduction also. And hello, Fox. This is Leo speaking. Together with me is Naomi from Stratasys. And as you saw before, let's have a video first. So you find on the next slide and also in the comments section below the link to the YouTube video about a small introduction to Polyjet printing, and we will come back to the question and answer round in 5 minutes. So enjoy the video, and I'm looking forward to your questions. Actually, the video. As said, we are now here for your questions and answers, Naomi and me, and we have here already one question or some questions. About the...
Yes, so maybe I will also say hello. This is Naomi Kempfer, and Leo, if I may reply to Karen's question. So Karen is asking, when you print onto textiles with a polymer printer, can you wash the textiles after? So Karen, the answer is yes. We have done numerous testings, and we have proven that it is possible to wash the textiles in fine laundry that is up to 40 degrees Celsius in fine textile laundry. So that is the answer. Obviously, dry washing is always available. Dry cleaning is always available. Maybe next question. Are there other questions?
Maybe the question from Petra Meyer about the eco footprint. The eco footprint has several aspects, and one aspect would be to use in an efficient way these artificial chemicals. So the beauty about Polyjet printing is that you produce an object with a minimal amount of waste. So this aspect is here valid as well.
Yeah, what people sometimes need to take in account is that the footprint is, of course, the complete supply chain of production. One has to understand that we don't have any molds in 3D printing. There's no cost in creating the mold or material cost in that. For very small productions, it often makes a lot of sense to use 3D printing, small series, customizations. Imagine the footprint we should have realized if we would have done the same with similar materials in conventional manufacturing techniques. So it's indeed so that footprint is always, it's not an optimal solution, but it's always a relative solution. Comparison to other options and other techniques and other costs and the resources that are necessary for the earlier steps. Frederick is asking, what's the ideal topography of the textile to be printed on? So we are doing different examinations on different surfaces of textiles, if it is jeans, if it is meshes, if it is different kind of leathers. And we are indeed seeing that different textiles have a different quality of adhesion, and it depends on how well the polymer particles are absorbed inside the textile, where after they are consolidated into the textile and are stable on top of the textile. So in fact, the porous textiles seem to work very well. The meshes and the porous textiles, as well as the leathers, each material to be tested separately. This is also part of the research. To answer Karen Fluke, we did not recommend washing in 90 degrees. For the timing, we have proven 40 degrees, but we do not recommend the 90 degrees.
About the cleaning of the wastewater used, respectively the materials or the part, if I get that right, can remove the let's say the parts, the support part by mechanical force or by a water jet. This means you have objects there not in the water itself, but as an object, and this is fully cured and you can throw it away like a conventional plastic part. If I get that question right. to the question from Frederick, you mean the viscosity of the material? I didn't get the question maybe right. Because in Polyjet you have also a viscosity of the material itself, of the ink itself. So here I'm slightly confused what you mean.
Okay, to answer Frederick's question, the Polyjet materials are ranging from very soft rubber-like materials to durable, rigid materials, and any combination between the soft and the rigid materials is possible. We call this digital material. So at any pixel level, at any micron level, it is possible to define the physical properties of the material that is being printed. One does have to consider that when you print on textile very soft material, what geometry do you want to offer it? Given that it is very soft, it will be able to withstand better certain geometries than others. This is the only consideration. But to answer the question, yes, it is definitely possible to print in the different material durabilities. Another point is just to clarify on the term viscosity. The polymer is projected onto the textile when it is not polymerized. It is so the viscosity is going to change in the process of polymerization. So I don't think this was part of the question. What is the material viscosity? We call it durability, and we measure it with Shore values. We recommend working with Shore values between 80 and 100. I see that the question about sustainability appears again and again. This session is not topicked. It's not a sustainability project. There is a sustainable aspect in this project, but this is not the focus of our project. There is a sustainability focused project in the session tomorrow, guided by our partner Fraunhofer, and we recommend those who are interested to work on the topic of sustainability to join that session and that project. There is a project that can be applied on the topic of sustainability. Are there other questions on the focus point of Polyjet technology? And I also want to recommend again, earlier I posted in the chat the link to the Stratasys Art, Fashion and Design website with many examples of Polyjet applications, different aesthetic qualities that Polyjet can offer, different fashion projects as well, and different videos showing the possibilities of 3D printing on textiles. Do we have any other questions?
Another question from Studio Frederick, as mentioned, a broad question: where are the challenges of the technology quite in general? Polyjet is a nice nice method to indeed have multi-material aspects, a real multi-material aspect. The thing is, you can print several kind of colors, but also ranging from, let's say, stiff to flexible material in one printing job. That's the uniqueness of the technology. However, as the question indicates, and yes, there are challenges, and one is dealing with, let's say, the durability of the material property. This means when you have, for example, a flexible material, it should be flexible a long time. This is still an issue, and also when you think about colors and UV light, this is kind of the natural thing. This also happens here, and where the journey is going is to overcoming these issues here. Also in adding more material properties, more features. This is one aspect of the current challenge. If you want to add something more, Naomi, please feel to do so.
I'm seeing Shuba's question here about the submission of a 2D design. The focus here is, of course, 2D to 3D. So we are interested to find how would you translate the third dimension in your design. 2D print is a photo print, right? So our technologies are focusing on the third dimension. And I'm sure that you will find exciting opportunities to translate 2D surface design into 3D solutions. There are different software packages that would allow you to do that. For designers who are eloquent with 2D design and like to work with software such as Photoshop, also in this software package you will find a 3D application allowing you to translate your 2D designs into 3D solutions. So we recommend also looking into this possibility for those who come from the 2D specializations. I hope, Shuba, that this answers your question.
Question from Mikkel. Yes, the question was also raised before that when you choose one challenge, it's possible to use also other technologies from the different challenges. For example, the printed electronics part and the 3D printing part come hand in hand. So this is definitely possible.
A question from Ganit Goldstein. Is it possible to test 4D printing processes with Polyjet technology? It is possible today, and there are different experiments on the topic of 4D printing. The fourth dimension being time, where the geometry is going to react over time and might open up or close down depending on a change in the surrounding parameters. This is definitely a topic that can be focused in the research project. Ganit, does this answer your question? In personal contact, Ganit, we can offer you some examples of research that has been done in the 4D printing domain, some research from MIT and other universities as well. We'll be happy to share. Do we have any other questions? We also want to recommend for those who are interested in combining metal insertions into textiles and smart technologies to join the session tomorrow morning. Okay. Leo, do you want to, we will pass on the webinar?
I think so. So thanks for your questions, and let's enjoy the next session. The next speaker or the next session will be about visual modeling by AMPA Technologies. It will start in a few minutes. Until then, you still have some time left. Nevertheless, if you have additional questions, add it to the chat or to the help desk. We're happy to answer your question then later on as well. Until then, see you.
Hello, this is Agnes from AMPA. I hope you can hear me well. So first, I would like to invite you to look at our video about virtual modeling of body clothing interaction and human-like mannequins. You can click on the link below in the description box below our live stream, and we will come back here in about 10 minutes. The video lasts approximately 9 minutes.
The models that we are developing at AMPA
They are basically simulation tools that one can use virtually without having any prototype made. So we can think about fabrics, think about designs that we want to use and applications, and try them out fully safely without investing any money, any time, because it's very short period of time that you need to do this simulation, and try it out first fully virtually in the computer. The principle of modeling that we are applying here is to connect several different models developed by other researchers, but also here at EMPA in-house, in a series of models that communicate with each other in a real time. So to this series belongs human thermoregulation model, thermal sensation model, and model of the clothing that includes all the physical phenomena that occurs within the fabric, but also in the air layers underneath the clothing.
A model of human thermoregulation considers different layers of the human body, which are bone, fat, muscle mass, different skin layers, which have different properties, thermal properties, which in the end affect the heat transfer within the layers as well as on the surface of the different layers. Based on the heat transfer within layers and the interaction between the layers and its environment, we have thermoregulatory responses. The basic principles of human thermoregulations is to maintain the core body temperature between 36.5 and 37.5 degrees Celsius. To do so, he has like different responses. So there is on one hand vasomotion, so he can increase or decrease perfusion in the segments of the human body in order to increase heat loss or to decrease heat loss. If we get too cold, we start to shiver, which is like heat production by muscles. And when we get too hot, we start to sweat. So we increase heat loss by means of evaporation.
Thermal sensation model is a kind of statistical model developed on a large database of data from human studies, where people were asked how they actually feel in different environments. So different models are available from literature, and we try to apply them. So we are using the physiological data that we obtain from thermoregulation model to attribute them to actual thermal voting. So the clothing model that we developed here at EMPA consists of the model of the fabric, meaning polymer or natural materials with air between the yarns. And the second very important part of the clothing model is simulation of the air layers underneath the clothing. Since air is a very good insulator, that means that it provides bulk of thermal resistance of the clothing. So fabric actually has a quite small input to overall thermal resistance of clothing. Air layers under clothing can be determined in different ways. The first, more experimental way is to use a mannequin, dress it with the clothing, do the 3D scan of that mannequin, and do another scan with a nude mannequin and superimpose these two pictures, and then we can obtain the distance between the body and the clothing. However, for that, one needs already a prototype, already clothing. A more virtual and faster way of doing it is to use 3D try-on software. For example, there are several commercial softwares available on the market where we can create 2D pattern virtually, put it on the body and bring the body to move. So we can export then body and the clothing already draped around the body and work with that avatars and obtain the distance between the skin and the clothing. So one of the practical applications where we used our model was developing of the ski jacket with our commercial partners. where the task was to determine where panels that are transporting liquid moisture to the outside of the garment and keep you dry and warm should be placed, and what other conditions should be fulfilled so that the sweat moisture coming from the body during skiing comes to the inner surface of the jacket and condensates there, so that it can be transported by the active panel to the outside of the clothing. So the mannequins that we have in our laboratory, they have a human-like shape, anatomic shape, like the full body mannequin or the foot or the head mannequin. They can be placed in realistic conditions in a climatic chamber, and some of these devices, they can even move in a very human-like manner. For example, walking, like in case of foot mannequin or a full body mannequin.
With thermal devices, we can mimic the human body by the means of heat production. So with activity, the body produces heat, and this can be simulated by such kind of devices. Furthermore, we can look how skin temperature, how the surface temperature of the device changes based on this heat production, and this somehow mimics the change of skin temperature as well. Finally, we are able to apply clothing layers as well on these models in order to investigate how clothing layers affect heat loss and heat gain. In addition, we are also able to simulate the effect of sweating from the human body, which is perspiration from the model to the fabric layers to look at the moisture transport and how it affects the cooling of the body. And we can look at movement patterns as well, so how movement affects air layers within the clothing systems, and in the end how this affects insulation of the clothing.
We have the whole family of different thermal mannequins that we are using for different purposes, starting with head mannequin, foot mannequin, hand mannequin, torso mannequin simulating a human trunk, and ending with a complete body mannequin with anatomic shape. Head mannequin is used mainly for testing headgear, for example motorcycle helmets or bicycle helmets, as well as any headwear that is used in cold environments. We can place also our head mannequin in a wind tunnel to simulate high wind speeds, like for example in case of riding the motorcycle. Our foot mannequin can simulate walking movement with a realistic pressure exerted from the ground, and we can test with that distribution of moisture and distribution of pressure in the shoe and its influence on its properties and thermal sensation while wearing the shoes. We also can test socks and other devices that are used on the foot or close to the foot on the leg. The torso device is used for testing different fabrics and structures that can be used on the main body of the human. We can regulate air layers so that we can test how the garment should be fitted to the body to optimize its thermal performance. Finally, the full body mannequin is used for testing final prototypes that are made for human use. And this is usually used to confirm if the prototype is functioning or to compare the new product with competitors that are already on the market or with the previous products and see if the performance is improved. And this testing is usually the final stage before we test it with real people. So welcome back to the questions and answer session. We are waiting for your questions, which you can post in the live chat. In the meantime, maybe I can elaborate a little bit more on what you can do with our technologies. Basically, if you are asking yourself about a little bit more than just aesthetic aspect from the designs, which you may have in mind, and you would like that this design also is interacting with the human body or has a certain function that is dependent on the human reaction. For example, It might be reacting if one feels too hot, or reacting when one starts to sweat, or reacting when one starts to feel too cold on the entire body or somewhere at the extremities, or can determine certain body reactions and interact to that. For example, increase the insulation or prevent sweating or absorb the sweating from the body to feel warm and dry. So this would be the tool that you could apply in this case, and test if what you are thinking is the correct way to go, and when, in which temperatures or in which conditions the interaction should take place. So that would be one possibility. The prototype, once available, could be also tested directly in our laboratories on the devices that you could see in the film. So we've shown just few of those. We have some other possibilities also, and we always discuss on an individual basis depending on what is needed for the project, what is needed for the prototype, and what question is posed in the project. So the question is, have you ever tested 3D printed clothing or unusual materials? We work with shoe manufacturers on different types of soles and footwear that is individually shaped and functional. So that was definitely a big challenge. Also different types of socks that were made in a very unusual manner, where we were alternating different fibers. So for this, we had to develop special methods how we deal with that. We also work with ballistic protection, which needs also a special printing or preforming to fit to the body. So for that manner, we also have some expertise and different tricks that we need to apply so that we can actually test it and approach it with our testing devices in the laboratory. Are there any other questions? Frederick is asking, what about fluids like swimming suits? Unfortunately, we do not have any possibilities to immerse our mannequins fully in water and see what is happening there. But we have possibilities to test material alone in a smaller sample on a variety of smaller devices. So depending now on your question, I mean, swimming suits, this can be many things, moisture management, the aerodynamic shape, and so on. So if you have something particular in mind, feel free to contact us directly or via help desk so we can elaborate on that. Next question from Yulia. What is needed for improving for your devices? I'm not sure what is meant by that. Our devices actually can sweat and move, so they are already pretty close to the human natural behavior. They can be also heated. They can simulate conditions close to human use, with including skin temperatures and humidity at the skin level. So, so that is definitely something that is already existing. If one considers very hot environments like firefighters situations, these devices cannot absorb that much heat. So here something else, some other methods need to be applied. But for this, we also have some customized solutions. So if there is a need, we can continue dialogue on that. Another question from Michał. You have mentioned virtual avatars. Can they be based on 3D scan of a particular person? Yes, this is absolutely possible. There's 3D software, which is a commercial software we are using, is offering this option. And we can definitely scan somebody. I mean, our partners, they are offering 3D body scanning, but we also have 3D body scanner in-house, so there is no need for traveling. We can do it. We can address that issue here on site, and also use that scan to put on virtually the clothing and determine all parameters that we need for further simulation. Another question from Julia. They need to optimize for each material. How do you do that? Well, we use our devices in a close to end user situation. So finally, if you mean that the prototype that will be created within one of the projects should be worn by people. So this is basically what you need. So it doesn't matter which material that is. We are mimicking human-like conditions. So if there is no need to adjust our devices to the material, because we need to adjust our devices to simulate human body, because if it won't work with the human body, then what's the deal of having that prototype at all? So here, the major focus of our tools and technologies is to mimic human body and try to give you the best advice on the function and interaction between the prototype and the human physiology and human thermal comfort, but also wearing comfort. Another question is, have you worked with smart textiles? Yes, this is what we do quite often. So the special functionality of the textiles always depends on the application. And then we have to set up our models or our devices to be able to test if this functionality is available or if it performs as desired for these conditions. So the major difficulty here is to develop a scenario which will be sensitive to that particular application. But this always has been reached. So in the video, you could see one of the practical examples that we've worked on here. This was a ski jacket that needed some modeling to find the optimal place where to place the panels so that we make sure that the sweating moisture is condensing on the inner side of the jacket and the active panel can bring the moisture to the outside of the garment. If the panels were placed on the lower body, the condensation would not be possible and they would not be working properly and removing any moisture from the system. We also work on a variety of different projects developing sleeping bags, sleeping tents, shoes, different body monitoring devices, such like t-shirts with integrated sensoring, or with certain functionality to keep body dry and warm in winter, and enhance cooling in summer by spreading and helping evaporation and cooling of the body. Another question from Studio Frederick. Do you have measurement data available that could be potentially useful for design purposes, coding? Well, this is a very general question that you are asking here. This really depends on the application now. So we've went through quite many prototypes. We also do ourselves subject studies for different projects. So here you have to be more specific because we have loads of data and potentially this could be exploited or explored in this project here. And another question from Karin. Are you also developing the three-dimensional pattern making programs? We are working on digital design, but we don't work from flat patterns, but we program the sphere in the flat plane of the textile. So in this area, we are not active as developers. We are simply users of these programs. But if you have any design already created in this three-dimensional space, we can take it from there further, and we can evaluate the air layers and then next steps with all the heat and moisture transfer through these layers and effect on the human body and interaction of that human body. So we only cannot develop specific very complex surfaces if this is not via using the commercial software that we have in lab. But if you can provide already that 3D forms or avatars with the 3D pattern already applied on the body, we can take it from there further. So another question from Studio Frederick. Let's say about aerodynamics. Air current flows around the body in different environmental conditions, wearing different textiles, proximities to the body, etc. Yes, this is basically a large database that we used for developing our thermal models and thermal comfort models. So there is definitely a database available that could be explored in different ways that we've done it till now. Or maybe after a deeper discussion, we can discover that actually we are following the same aims and you could use directly our developments and our algorithms that we already developed for our purposes. Yes, the raw data is available to answer your final question from Studio Frederick. I think we are way ahead of the time, so I probably conclude the session. We are meeting tomorrow again for another session at Hub Berlin with different technologies being introduced there. So I hope to see you all there. We will be also presenting as a part of that hub as well. And for today, thank you very much for watching, and thank you for your questions. And if you think about more questions, please do not hesitate and write to us via help desk. Thank you very much. Have a nice day.